Hello everyone. Am I audible? Nice. Let me share my screen. Cool. Welcome everyone. Uh, Let us wait till 9:10 to start. Cool. So yeah, we are going to learn LLD and object-oriented programming today. So yeah, just wait a minute. Oh, are there some more patches as well today? Hmm. Okay, मजाक कर रहे हैं लोग. Hmm. Oh yes. So today's scalar edge people have also joined this session. So there is one difference. Cool. We'll be starting at 9:10. Okay. We're starting at 9:10 p.m. Cool. The scalar edge people are, I think, the fourth year students. Now they will be in fourth year or probably just graduated. So yeah. Yeah, I mean, the scalar edge students are across the horizon. So they might be first year college students, second year college students, third, some fourth as well. So the whole variety is there for scalar edge. So today's this class is going to have a huge variety of people. Yeah. Maruti, LLD is going to be conducted together. LLD is going to be conducted together of these as well. Manish, today we have around 150 attendees. HLD and project module will be taken together. No, after this, I mean, after the LLD module finishes, you will have an HLD module which will be completely different, instructors, everything different. And then there will be a complete project building module. So, all of them are separate modules. Uh, no, I haven't moved to Scalaverse. I'm at my hometown only. So LLD is going to be around 18 classes. HLD will also be around 18 classes. And project building will be, I think, 12 classes or something. Okay. So 20 classes. I think you can expect 6 weeks for this, 6 weeks here, and 4 weeks here. So total, you have around 3 to 4 months of course left. Yeah. Yes, good point. So for project building, there are going to be 12 classes for front end, and then there are also going to be 12 classes for back end. So both of these will be taught to everyone. Okay. So front end and back end both will be taught. So 4 weeks of this, 4 weeks of this. So you can expect the whole course is around 5 months now. Venkat, all of that will be discussed today. Don't worry. Okay. Backend is of two classes. Sorry, backend is in two languages: Python, which is using Django, and Java, which is Spring Boot. These two things. Okay. LLD, the classes are going to be for Java. By the way, here also, I think for Django, there is a recorded material. Live classes are going to be there for Spring Boot. So I think this is the difference between these two. Sure and sure. Yes. So for everyone, both front end and back end is going to be taught to everyone. So now it's not a choice that either choose front end or choose back end. Both are going to be covered in a sequence. So first, either front end will be covered or the back end will be covered. Then the second one will be covered. Okay. Yeah. Yes, Pariti, all of that is the agenda for today. Yeah, IntelliJ license is going to be given to all of you, and you will be receiving the license of IntelliJ by end of Thursday. Okay. No, Priyanshu, the live classes of backend are going to be in Java, and the live classes of frontend are going to be in what we say your I think React, Node.js, and things like that. Frontend framework will be React. Yes, Shashank, Spring Boot will be covered. Don't worry. Okay, I think 2 more minutes and then we will start the session. Utkarsh, microservices will be discussed in HLD. There are so many people are saying that I look different without beard. Itna bhi nahi hai yaar. It's the same thing. Does Scalar provide any module for competitive programming? No, Nishant. The DSA one is more than enough. Since we have Spring Boot for backend, will we have JSP for the front end of Java projects? Yogeshwar, I am not sure about it. It will be better if you ping regarding project module, right? Anything related to front end and backend. Please ping Arnav. Arnav Gupta leads that module, so he will be more than happy to give you any questions or any resolution that you might need with respect to these modules. Yeah. Yes, Ayush. I mean, in LLD as well as in your project building, we are going to code. Okay. Is Scalar going to give IntelliJ IDEA license? Yes, Scalar is going to give IntelliJ IDEA license. It will be given by the uh, second LLD class. Okay, before the second LLD class, you're going to get that license. Don't worry. Okay, so we are at 9:10 p.m. Let us start the session. Okay. So we have a huge number of attendees today in the session. We have almost 200 people now. So let us see how the session goes. Cool. Okay. Welcome everyone. Welcome to your very first LLD class. Today we are going to officially start the low-level design module. Okay. Thankfully, the very first class of the low-level design module is going to be a lighter one. There are not many concepts for most of you, but as we will proceed with the classes that are going to go ahead, the difficulty of the low-level design module will be growing kind of exponentially. So let me talk about the agenda for today. What are we going to discuss? So the very first thing that we are going to do is we are going to start with discussing what exactly is LLD. What is LLD? I mean, what does it entail? What are the different topics that come under low-level design? And why is LLD important? I mean, why are we teaching you LLD in terms of both interviews as well as in terms of a real job? That okay, where does low-level design actually help you? Okay, obviously interviews is one thing. You even if you apply as an ST1, you are going to get an LLD interview. But more important than that, LLD knowledge is going to help you in your real job as well. So we are going to discuss why LLD is important. After that, one question that comes up from everyone in the first class is what exactly are we going to cover in the low level design module? So we will discuss structure of LLD module, that what are the different classes that are going to be happening, what are the things that will be covered in each of those particular classes, and also the assignments that will be there for you. Okay, cool. After this, we will start formal knowledge related to the low level design concepts. So in today's class, we are going to just have an introduction to object oriented programming. Just a quick question. How many of you here already know what object oriented programming is? Say a yes if you already know what object oriented programming is. Say a no if you don't already know about them. I mean, just say with a vote of yes or no. So, I mean, we have around 10% people who don't know about it, but don't worry, it's going to get covered. Okay. So, we are going to start with introduction to object oriented programming. What exactly is object oriented programming? What is the idea behind object oriented programming, etc. After that, in today's session, we are going to just learn basic object oriented programming constructs. So, we will see what are classes, um, what is polymorphism, what is abstraction, what is encapsulation, etc. Whatever we are able to cover today by 11:30, we are going to cover that. Other topics which we are not able to cover, we will take it up in the next topic, okay, in the next class. So next class is going to be object-oriented programming 2, where we will go more into detail of abstraction, encapsulation, interfaces, polymorphism, etc. Okay. Now, all of these topics that we will teach in LLD will be practical. For every particular thing, we are going to write the code. In the classes, we are going to write the code in Java, but the concepts are going to be language independent, so don't worry about that. The reason for using Java is that Java has all the constructs in the most simplest way to explain, so that is why we are going to use Java. And you can Google about how to do the same thing in other language as well. If for any concept you don't know how to do that particular thing in some other language, just ask a TA request. So very soon, when you will raise a TA request for any LLD class, okay, when you raise a TA request for any LLD class, I'm not asking about a TA request for a question. When you raise TA request for a LLD class, you will be having an option of selecting the language. That do you want the TA request in Java, Python, C++? Okay, just raise the request in whatever language you are more comfortable with, and a TA who is experienced in LLD in that particular language will get on a call with you and will try to answer this question. Is that clear with everyone? I don't think you can select or prefer the TA, but there is the option of selecting a language is going to come very soon. Till that particular time, please feel free to raise a request, and in the comment, just add that I want a solution in Python, or I want to connect someone who is interested in or who knows Python. Okay, so that the correct TA gets assigned to you. And okay, so one story that I share with everyone, why we are teaching in LLD, there are two reasons. The very first reason is because Java is going to allow us to teach all the concepts in the most simplest way, and Java has all the concepts that exist or that we want to teach. The second thing is, when machine coding interviews or LLD interviews happen, many companies actually prefer if someone codes in Java. So the way we have structured this module is, even if you probably don't know Java prior to the classes, how we are going to advance in the coming classes, you will be very much comfortable with Java by the end of the LLD class. So by the end of the LLD classes, you're going to be very well comfortable with Java and the Spring Boot part. That is important for LLD and machine coding interviews. So don't worry about that. I know one student of a past batch who was able to get as a Java backend developer after just following the LLD classes. So that is a success story that I always keep on saying in every batch. So don't worry about it. If you don't know about Java, just be very attentive in the session, and feel free to ask any doubt if you have. Okay, cool. Vanda, for any other language, just feel free to raise a TA request on how to do a particular thing in that particular language, and TA will be more than happy to help you with that particular thing. Is it clear? Yes, Kumar. Okay. Anyways, let us start the session, and I am pretty sure almost all of the other questions that you will be having will be answered as we go along the session. So let us start with what is LLD, right? Now, LLD is an acronym for low level design. Okay. Now the question is, what is low level design? To understand what low level design is, let us try to understand the opposite of it. The opposite of low is high. High level design. Okay. Now, quick question. When do you use the word high level in your day-to-day lives? When do you use the word high level in your day-to-day lives? When do you use this word? When we are talking about overview of something, right? When we are talking about bird's eye view of something, when we are not going into detail. So often the word high level is used when we are talking about overview or bird's eye view or not going into detail. Okay. Now, what do I mean by this? See, all of us here are software engineers, right? So whenever we talk about something, we are talking about nothing but software systems. Okay. So in terms of software system, what does a overview of a software system mean? Let us think about a software system that is working in our day-to-day job. Do you think the software system will be very simple as that? Okay, there is a client, and this client sends a request to a server, and you get the data. That's it. Is a real software system that simple? That you send a request to someone, the server is running on the computer, on one computer, and you get the result. No, it's not that simple. Often, a real world production system is much more complex. Let us talk about a very simple application, a very basic application as well. There also, when a client will try to access that particular website, let us say google.com, do you think there will be only one server? No, there will definitely not be one server. There will be multiple servers. So behind the scenes, there will be multiple Google servers. Okay. Now, if there are multiple servers, who will client talk to? Client will talk to someone who is sitting in between the servers and the client, correct? So that someone is known as a load balancer. So client often talks to load balancer. You don't need to understand what load balancer is. That will be discussed in the HLD classes. But I'm just trying to tell you what I mean by a complex software system. Okay. So a client talks to someone like a load balancer, and this load balancer is going to send this request to one of the different application servers that are sitting behind the scenes. Is everyone clear till here? Okay. So client sends a request to a load balancer who is like an intermediary, and that intermediary forwards that request to one of the multiple application servers. Okay. Probably the application server that is most free. Okay. Cool. Now, do you think the application server will do everything within itself? I mean, is application server self-sufficient? Is it going to do all the work, all the data storage here only? No. Often application servers have to store the data, and they don't store the data within themselves, but they use special machines that act as databases, right? So there is a special MySQL server, or there is a special MongoDB server, or there is a special any database server that they talk to. So often these application servers will be talking to a database. Okay. Now let us imagine an application of Google scale. Do you think a single database machine will be enough for that? No, a single database machine is not enough. There will be many databases, right? Your data will be distributed across multiple machines. So often that database also ends up getting replicated or sharded, whatever. All of these things you are going to learn in HLD. There are multiple other things as well. There are multiple other things that are involved in the low level design. There's a question by Maruti. Isn't application server a database? Maruti, often the database is not installed on the application server. The database is a separate machine for most of the real production code bases. You have a separate machine that only acts as a database. Now, why might you do that? The reason for having a separate machine for a database might be because the application servers might be CPU intensive. You might build application servers such that they have high CPU, whereas databases might be high storage systems. So that is why you try to have specialized machines for specialized operations. Clear, Maruti? Okay. Yeah, app server is the backend. App server is the backend. Okay, cool. Now, this is a high level overview of a software system. Is everyone clear with that? So high level design deals with, so what is HLD? HLD deals with design of different infrastructural layers that work together to serve an application at desired efficiency. Okay, so what are the infrastructure layers? Each of these elements is considered as an infrastructure layer. Load balancer is an infrastructure layer. Your application servers are an infrastructure layers. Your databases are an infrastructure layers. So HLD deals with what are the different infrastructure layers in my system that will work together to serve the application at a desired efficiency. For example, the desired efficiency might be that, okay, for Uber, or let us say for Google search, I want to send the result within less than 1 second. That might be the desired efficiency. So how will you build a system for a huge scale with the desired efficiency? Pariti has a question, not clear with the application servers. Pariti, application servers are the servers where the backend is running. Your Spring Boot, your Django is running. Okay. So these are the application servers where the backend code base is running. Okay. Yes, Ponuru, it is. You will learn all about that in HLD. You will learn all about that in HLD. Okay, cool. Now, that is what HLD is. See, high level means a overview. We are software engineers, so we are talking about high level of a software system. What is high level of a software system? High level of a software system includes the different infrastructure layers that will work together to serve the application at scale. Is everyone clear with what HLD is? Is everyone clear with what HLD is? Okay. Yes. Yes, Prince. Each of these is a machine. Each of these is a real machine. Database is a real machine. Your application server is a real machine. Even the load balancer is a real machine. Okay. Cool. Now, let us just go a bit into depth here. What do you think is running in the database? I mean, what is running on the machine that is the database? I mean, this is a server, right? Why is it a database server? I mean, who called it that, okay, you have to be a database server? Pariti, the code is often there at the client machine. Okay, for front end, the front end is often there, often somehow sent to the client. Okay, who decides that, okay, this service will be a database? Who decides that? Quick question: can your laptop using which you are attending the class, can that become a database server? Can that laptop become a database server? Yes, it can. How? How? You just install the application. If you install MySQL on your machine, or if you install MongoDB on your machine, will your machine act as a database server? Yes, it will. Okay. Now, who decides that I have to act as a load balancer? Who decides that this machine will act as a load balancer? I mean, what exactly is the difference between this machine and this machine? The application that is running. Here, load balancer is nothing but the application. Here, this machine is running the load balancer. Okay, this machine, what is this machine running? This machine is running your backend code. This machine is running your backend code. So can I say at the end, in each of the infrastructure layers, there is code that is running. In the database also, there is a code. The code is of the database server. Here in the application servers, it is the backend code. In the load balancer, it is still the code. So inside whatever infrastructure layers that I have, there is a code that is running there. Is everyone clear with that? So there is some code that is running on every machine, and what type of code is running there decides what type of machine it is. If it is running the database code, it is a database server. If it is running the backend code, it is the application server. Okay. So can we say when we go into internals, the only differentiator between different infrastructure layers is nothing but the code that is running there. Okay, so this is how LLD comes into picture. LLD is the exact opposite of HLD. In the HLD, we are talking about the overview. In the LLD, we go into detail. So LLD, which stands for low level design, talks about going into detail. Now, detail of what? Detail of, again, software system. Detail of software system. Now, by detail of software system, I mean how is a software system implemented? Okay. Now, whenever I write any software system, a software system is nothing but code. You write code, right? Yes, I mean, Utkarsh, software system is nothing but an application, okay? So, any program that you write is nothing but code. So, your software system is implemented via code. But for real world projects, do you think that, I mean, till now, you would have only coded in data structure algorithms, right? But do you think in real life projects, there is only one file which has the code and the whole application is done? Not really. In the real life, there are going to be huge projects, right? A lot of files. So LLD deals with what all packages will be there, what all classes will be there, okay, what all methods will be there, all of those things, all of the things related to implementation of a software system. Like how are you really implementing a software system? What are the different classes that are going to be involved? What are the different packages that are going to be involved? What are the different modules that are going to be involved? What are the methods inside every class? And another important thing, how are different classes going to talk with each other? All those things. This comes under LLD. So LLD, we can say, deals with how to write the code, how will the code be structured, and everything around the same. Now, why are we so much interested in the code? So I think there are a few questions. Is LLD and architecture same? Shashank, often HLD stands for architecture. Okay, LLD doesn't stand for architecture. HLD stands for system architecture for most of the times. Okay, but sometimes architecture is used even for LLD. Okay. If it is the client code, then it is in the client machine. Correct, Manish. I mean, normally the client code is nothing but sometimes the front end code. Okay, for example, if you are accessing this website, the front end code is currently sitting on your browser. Okay. Okay. Who coined the term LLD? Not really sure about that, Manish. Okay. In fact, what I have heard recently is LLD is. So I was taking a class for for Scalar US, and LLD is not a term that US people know. LLD is a term that is more famous in India rather than US. In United States, LLD is known more as object oriented design. Okay, so if you probably ever end up giving an interview at a United States company, you will probably encounter the term object oriented design rather than low level design. So, just wanted to mention one thing. Okay, cool. Rahul, HLD is not like interface. HLD is basically coming up with these architectures. Okay, that okay, how will the complete system work? Okay, anyways. Tanajit, going there. Okay, just give me some time. Okay, let us not go ahead. I will come to UML diagrams, everything. Okay, cool. Now, quick question is that okay, why are we so much interested in the code? I mean, why are we having 18 classes just to tell you how to write the code? I mean, we are not teaching you a programming language, we are not teaching you anything, but we are saying whenever you write code, structure your code like this, make these packages, make these classes. Why are we so much interested in this? Let us get into that. How many of you here are software engineers? Just say yes if you are already a software engineer. Okay, so almost everyone here is a software engineer. Quick question. In your day to day job, be very honest. Or let me actually run a poll for this. I will run a poll for this. In your day to day job, how many hours of your day do you really spend writing code? I mean, where you are actually writing the code. Let me actually start a poll. Let me actually start a poll and let us see this answer. Okay. So let me quickly start the poll. So let us say I'm going to just write quick things. Okay. So I am just starting a poll. Let us see what the answer is. How many hours of day do you spend actually writing the code? And don't select the option C just because it looks cool. Okay. How many hours of your day do you actually spend writing code? Okay. So yeah, here if we see almost, if I say 16 plus 32 plus 38, which is almost like 70, 86% people here are saying 86% people here are saying that they spend less than 3 hours of code, 3 hours of a day writing code. Okay, so normal working day is of like 8 hours. Out of that, 86% people spend less than 3 hours. Even if we go here, let us say, if we say less than 2 hours, less than 2 hours, 70% people. 70% people just write code for less than 2 hours per day. Now, let us say a software engineer is paid something like, let us say, 40 lakh per annum these days. That means, can I say that they are only working for 25% of their time? If a normal working day is of 8 hours, they're only working for less than 2 hours. So they should just get 10 LPA. The other thing, they're just wasting the time. Not really. Quick question. When you are not writing the code, what are you actually doing? The activities that a software engineer is doing when they are not writing the code, they are debugging. Debugging is something that everyone is saying. Okay. They are analyzing. Probably they are analyzing the requirements, or they are trying to understand how the code is working. They have meetings. Yes. They are documenting the code. Documentation. Correct. Code reviews. Correct. People are doing code reviews. Testing. Yes. You are writing test cases, etc., etc. Anything else? Deployment. Okay. Anyone drinking coffee? Okay, so Tapan is my favorite student. So Tapan is saying he spends that particular time solving scalar assignments. Fair enough. I mean, you spend that solving scalar assignments as well these days, coffee. But let us get to the practical. Let us get to the real things. Okay, so mostly documentation, code reviews, etc., etc. Okay, okay. Now let us get to these parts. When a software engineer is not actually writing code, they are doing these works. Let us try to understand that. When you are doing debugging, or when you are, so basically debugging is nothing but if your code has a bug, you are trying to find why that bug exists. So to find why that bug exists, what will you need to do? What will you need to do? I mean, you will need to debug, but how do you debug? How do you debug? You go inside the code. That means you have to read the code. Okay, so you understand the code, that, oh, this is what I'm doing here, this is what I'm doing here, oh, this is why the bug is happening. Everyone can relate to that? Can everyone relate to that? Perfect. Now, analyzing. What might you be analyzing most of the times? I mean, the word analyzing is used in multiple ways. One is to analyze the performance. Sometimes analyzing is for requirements. So you often end up analyzing requirements. That, okay, what exactly do I have to build? Your product manager or your manager comes to you and say that, hey, Prakash, you have to build a system that does this. So you are trying to understand the requirements, that, oh, my program has to support this use case, my program has to support this use case. Sometimes you are analyzing the code as well, so you are analyzing the performance as well. Okay, cool. Now when you are analyzing the requirements, you are analyzing the requirements from who are you going to analyze the requirements with? I mean, who gives you the requirements in your day-to-day job? Program manager, your business analyst, your product manager, those kind of people, right? Okay, so often you have to analyze the requirements. Performance, to understand why is the performance slow, what do you need to do to identify why is the performance low? Again, you will end up, I mean, you will monitor and you will do the performance check, but eventually it will come down to debugging and then reading the code. Again, it comes down to reading the code. Cool. Okay. Meetings. Why do meetings happen? Why do meetings happen? Again, requirements. Meetings are nothing but requirements. Documentation. Documentations are done to again explain the code. Documentations are nothing but to explain the code, to explain how code works. Okay. By the way, often it is told that a good code should ideally not even need documentation. A good code documents itself. Often, if you have to write a documentation for a code separately, what are the problems with that? What are the problems that can happen if you write documentation separately? Time, okay, time is one thing. Something else, need to maintain the documentation. What if you change the code but you forgot to update the documentation? Documentations can end up becoming stale easier. That is why it is often preferred that if you are writing the code, write code in a way that it documents itself. Okay. So yeah, I mean, there are multiple types of code bases. So yeah, code review. Again, when you're doing code review, you have to nothing but read the code, right? Because that is how you will try to understand it, what it does, and then you will do anything about that. Testing is again same as debugging, reading the code, analyzing it, etc. For now, let us ignore the other parts. I mean, deployment, scalar assignments, coffee. Those are important, but we can ignore them. Means adding comments. Utkarsh, I mean, code review. See, to add the comments, you will first have to read the code, right? Till the time you don't understand the code, will you be able to even do code review comments? Not really, correct? So that is what I was saying. When you're doing a code review, there also you are reading the code first. Clear? Okay, so means adding comments. Yes, Utkarsh. By documentation alternative, I mean not even comments in the code, but probably sometimes the code is so clear, the code is so well defined, the methods are so well defined that the code documents itself. It is even much better. If you have named your methods well, your code will definitely document itself. You don't even have to document it separately. Clear, Utkarsh? Awesome. Now, let us just go into these things. In fact, what we saw today isn't really something that only scalar students are doing. Scalar students are not uh, Kamchor type of thing, right? There was actually a research that was done. And in that research, it was found that an average software engineer only spends 12% of their day writing code. Okay. That means the remaining 88% of the day is spent doing the auxiliary activities. It is spent reading the code. It is spent understanding the code. It is spent understanding the requirements. And this 88% of the time is the time that LLD optimizes for. So why is LLD important? LLD is going to make the 88% of work that you do easier. Okay. So basically, it is going to help you write code that is easy to read. Now, let us say, okay, first of all, do you think reading code is difficult? Is reading code difficult? Not really. Reading code is not difficult. Understanding the code is difficult. I mean, reading, anyone can do, right? Reading is the same thing. Just go and read the code. But understanding it is difficult. LLD helps you write a code that is understandable. It should not take much time for you to understand the code. You just read the code and it makes sense to you that, oh, this thing is happening here. This thing is happening here. Let me take you an example for this. So I was working on a project a few years ago, 2, 3 years ago, and there they had such a brilliant code base that I once encountered a bug there. And without even going into the code, I had not gone into the code. I just assumed that there will be somewhere a class called page, and in that class called page there will be a method called see threads. And after that I went to the code, and in fact there was really a method called that there. Such is a quality of a good code. A good code is something where you don't even have to uh, read the code to understand it. You by default can assume that okay, there will be some class called this, there will be a method called this, and that's it. It makes your life so much easier. It makes your debugging so much easier. As soon as you encounter a bug, you know that, oh, this bug might be coming from there. Is that making sense? The quality of understandable code so well defined that it doesn't even require extra mental efforts from you to understand what is happening. Yes, Sanket at Google. Okay. Now, the second property of a The second thing that your LLD is going to help you with is requirement gathering. Okay. See, as a software engineer, we are going to fail in our work always till the time we don't understand the requirements well. The very first step of a software engineer actually starts with understanding the requirements. If you are not clear with the business use case properly, in fact, I was talking to one of the CTOs very recently, and that CTO mentioned that the good software engineers that they have had are pseudo product managers as well. They are so good in understanding the requirements, they ask so good questions to the product managers that they in fact often end up doing better than product manager as well in the product thing. They ask them genuine questions, they ask them edge cases, and these knowledge helps them write bug free code. How many of you have seen the issue that happened recently with Infosys and the income tax website? Right, Infosys I think worked on the income tax website, and the website was, I mean, it was broken like anything, right? That is a bad thing, right? Ideally, the engineers who are working upon that should question their product managers on the face, that okay, how am I going to do this, what is the load that is expected, everything, so that the quality of output is brilliant, that people love that. Okay, so requirement gathering is something that they love. Then obviously, now let us say if you are working upon a code base, do you think once you write the code base you are done, nothing has to be done after that? Not really. What happens, the only thing that is constant in software engineering is, the only thing that is constant in software engineering is change. In software engineering, change is always going to happen. Your product manager is never going to be satisfied. Today you write a product, tomorrow they are going to come up with new requirements. They will say that okay, now we have to change this. Either they will upgrade the current requirements or they will add new requirements. So a good software should be extensible. What is extensible? An extensible software is a software which is going to be able to cater to new requirements with ease. Okay, let me give you an example of this. Let us say I am a software engineer at Scalar. Okay, I am a software engineer at Scalar. Anshu and Abhimanyu came to me and they told me that okay, we want to implement Scalar platform. Okay, I coded Scalar platform within 2 days in a very hacky way, and the platform is working. Okay, everyone is happy, everyone is praising me. After 2 days, they come to me and they say that oh, we actually have to now add this new feature as well. Now we want to add bookmarks in the classes. And to add that bookmark, I have written code in such a beautiful way that it is taking me 2 months to do that. Will they be happy with that? Not really. So, what needs to be there in a good software system is it should not just be produced very fast, but in future as well, because there are going to be a lot of changes that will keep on coming, a lot of feature requirements will be coming up. Your code base should be written in a way that is it is very easy for you to cater to new requirements. How will we write such code? We will learn in the coming classes, but this should also be a property of a good software. It should be extensible. It should not take much time for you to add new features. Okay. Then there is another feature which is maintainable. What is maintainable? See, let us say even if the new requirements don't come, no new requirements are there, but will that, I mean, can it still happen that you are required to change the code? No new requirement, but still you have to change the code. Why? Why might that happen? Why might that happen? No new requirement, but still there are some code changes needed. Performance optimizations. Okay. There might be some bugs. Then it can happen that the library that you are using or a third party dependency that you are using, let us say, changes. For example, if you were using JUnit, how many of you remember a JUnit problem, a JUnit issue that happened a few months ago? JUnit had a security vulnerability, right? JUnit had a, sorry, Log4j, sorry. Log4j. Log4j had a security vulnerability. And almost every code base that was written in Java was using Log4j. Now imagine if to just maintain that system, if to just handle library updates, it takes a lot of time for you. Is it a good situation? Not really. So what is a maintainable code base? A maintainable code base is a code base which is going to not make it much difficult for you to do optimizations, to solve bugs, to handle updates of the dependencies. Is everyone clear with this? Is everyone clear with this? Perfect. So one question that often ends up coming is, what is the difference between extensible versus maintainable? Quick answer is, extensible deals with adding new requirements, new features, whereas maintainability deals with supporting current features. So maintainability is supporting current features, whereas extensibility is adding new features. Is everyone clear with this difference? Because it's very important one. So Shanvaz, maintainable is, let us say you write a piece of code. Now, even if there are new product requirements, there might be some changes that might be required from you. For example, there is a bug in the system. Now you have to solve the bug. It will require changes. There is some performance issue. You will have to do performance optimizations. Let us say your code is using a library behind the scene, and that library needs an upgrade. You will have to update your code. So that is maintainability part. Your code should keep on running in future. Okay, so a code written once should keep on running in future as well. That is maintainability. Whereas extensibility is, your code should be able to handle new requirements as well. Clear, Shanvaz? Okay, awesome, cool. So what is a good software, or what we are going to achieve via the LLD classes, is a code that is understandable, a code that is extensible, a code that is maintainable, while ensuring that you also learn things that are other than writing the code, which is requirement gathering, etc., so that eventually you end up becoming a great software engineer. Okay, now let us just quickly take a detour and let us just talk about why is LLD important. Why should you learn that? Okay, we have discussed the software engineering part already, that it is important in your day-to-day job because that is the work that you do for 88% of your time. But for the interview perspective, many of you here might also have an interview as a goal as well, right? For interview perspective, these days, if you are applying to companies, even for STE1, okay, if you apply to top startups, even for STE1, you will at least have one LLD or machine coding round. Okay, for example, if you apply to startups like Cred or even Scalar for that matter, or let us say Unacademy, your Flipkart is one of the best examples for this, Gojek, even for STE1, you're going to have at least one LLD or machine coding round where they are going to check these skills of you. Now if you are applying at MNCs, okay, companies like your Netflix, Stripe, Google, they are going to ask these things if you are applying for SD2 plus. In short, if you are applying at any company with 2+ years of experience, you are definitely going to have one LLD or machine coding round. And if you are applying for startups, at least in India, even for ST1, you are going to have one machine coding round. So it is important for you to know LLD if you are considering startups at any cost. Clear? Amit, not sure about STET. Okay, I mean the goal here is more of software engineering, so I know more about software engineering only. Okay. Utkarsh, there is one class completely on machine coding. Don't worry. Okay, all these questions will get answered. What about less than 2 years experience? Vanda, if you are applying for top startups, even for 0 to 2 years of experience, they are going to ask this. So Flipkart, Cred, Unacademy ask this for even a fresher. Does Google ask for machine coding? No, Karthikeyan. Google asks for Google conducts system design round only for L5, which is ST3, which is almost like 5 years of experience. Okay, if you are applying at Google for less than 5 years of experience, you are not going to get a LLD question or a HLD question from Google. Somit, that will not be an LLD question. Google doesn't ask LLD. I have taken interviews there, so I know that. I mean, Amit, they will ask system design. So Google never has LLD and HLD separately. Google only has system design, and Google system design is going to involve both LLD plus HLD. Okay, Google only has system design which involves LLD plus HLD. In fact, most of the foreign companies don't have LLD and HLD separately. They only have a system design rounds which internally talks both about LLD and HLD. Okay. Salic for Google, it is L5, ST3. Google has machine coding? No, Karthik, Google doesn't have machine coding. Okay. Anyways, uh, correct way, absolutely. So quickly summarizing it, if you are applying at, so company type, okay, and when. if you are applying at startups in India, okay, you are going to have LLD round even if you have no experience. So this is going to happen even for STE1, 0+ years of experience. Okay, so even if you are a fresher, you are going to have an LLD round in top startups of India. If you are applying for MNCs, for most of the companies, you're going to have for STE 2+. That means 2+ years of experience. Okay, but there are some companies, some companies might even ask for at ST1 as well, but most of the companies are only going to ask at ST2. And if you are, I think that is more than enough. This information is more than enough for you all. By the way, there are multiple types of LLD interviews that happen. There is going to be one class, you can see it in your schedule. There is one class completely dedicated on types of LLD interviews and how to approach the problems there. There we will discuss the 3 types of LLD interviews that happen: your theoretical rounds, your design rounds, your machine coding interviews, and your debugging issues. So don't worry, you are going to get all the details about that in the coming classes. Okay. Amazon and Microsoft fall in this category. So Amazon and Microsoft are kind of special. So Amazon and Microsoft don't really ask machine coding. Okay, they ask LLD questions, but they are more of LLD only design. They don't ask to code a complete working application. So wait for the how to approach LLD interviews class. You're going to discuss that in detail. Okay. Yes, Aditi, many people at Google, many people go at Google at STL4 without any time writing a software engineering product. So, it can happen at Google. So, if you are good in DSA, you can get to Google without even knowing how to write software. Not sure, Salik. Okay, anyways, we are going to discuss these types of interviews later. So, one last topic before we start learning for today is what comes under LLD. Under LLD. And another thing is, how is LLD module structured at Scalar? Okay, so at Scalar we have basically designed the LLD module into a few sections. So what are those sections? Jehu, this is the thing. Don't worry, you will have the notes. Don't worry about that. Okay. Cool. Pariti, wait for the class on how to approach LLD problems. You will understand that thing. Okay. Don't worry. We are going to go into complete detail of how to approach every type of LLD problem. Don't worry. Okay. So what comes under LLD? In LLD, in the scalar module, we have divided into multiple sections. The very first section of LLD module is going to be object-oriented programming. That is going to start from today, and that will end probably in the next class. Worst case, if the class is very slow, it might go up to 3 classes, but not more than that. So 2 classes is what I will take for this. After this, we will go to design principles. Here we will discuss a very popular thing which is called solid design principles. This will probably be covered in 1 class. Worst case, it will go up to 2 classes, but 1 class is more than enough for this. After that, we will go into design patterns. Okay. Here we will discuss all the different types of design patterns like creational, factory, singleton, factory, prototype, your adapter, strategy, all the different design patterns, builder, all those things. Okay. We will be covering in our classes around 10 design patterns. We will not be covering all the 24 design patterns, but all the 24 design patterns that are there in the Gango 4 book, we will be covering the important ones, the ones that you are going to encounter in the case studies, that will come in the interviews, or that are more commonly used even in the real software engineering environment as well. And you are free to learn about the other ones after that. It will not be much difficult for you to learn about the other ones after this. Obviously, for the design patterns, we are not just going to say that, okay, this is the design pattern. We will first build a use case for that. That, okay, what is the problem statement which requires us to use this design pattern? For example, if your class has a lot of attributes, you cannot take all the attribute via the constructor. So you will try to use builder for that. Something like this. So we will try to start from the problem statement. Then we will come to the solution of that. And then we will understand the pros and cons of that solution. when to use that solution, when not to use that solution. For design patterns, we will be having 4 classes. Sometimes it might go up to 5. So, but I think 4 classes should be more than enough. After design patterns, we are going to learn about UML diagrams. Okay. UML diagrams, 1 class is more than enough. Then we will have schema design. No, Siddhant, all the 3 types of design patterns: creational, structural, behavioral. Okay. Everything will be covered. 10 in total. 4 creational, I think 3 structural, and 3 behavioral. Something like this. No, Shanama, schema design comes in LLD. So we will be discussing schema design, how to design your tables, what attributes should be there, how to represent the relationships. I have not taught that to your batch, right? Did I take you DBMS classes? No, right? No. Okay. So here we will learn about how to basically make your classes into real tables, how to represent the relationships between those classes, how to put each type of relationship. For example, you would have heard about 1:1 relation, 1:m relation, m:1 relation, m:m relation. How to put each of those relations into tables. How will you represent each of those relations into a table? Okay. So here we will have 2 classes. Okay. In the 2 classes, we will try to at least take 3 case studies. We will almost have 3 case studies so that you have enough practice with this. Okay. Yeah, don't worry, Sugandha. It will be taken care much in depth. Okay. Okay. So Praveen, good question. So whenever we talk about schema design in terms of LLD, we don't really talk about schema design in terms of a particular database or in terms of a particular NoSQL database or an SQL database. Schema design for LLD assumes that you are having a SQL database. Because why this question even gets asked is the agenda of the interviewer is to see how well can you structure your thought, how well can you decide that, oh, this is the pattern and this is how I will try to divide my code base into a few divide my tables into a few sub tables, or probably denormalize the tables, etc., etc. Okay, so that is why with the schema design we are going to assume it's an SQL database. And that is what the assumption is with LLD interviews as well as machine coding interviews as well. Okay. Shanwas kind of. Okay. So wait for the schema design classes. Okay, cool. So we are going to have schema design 2 classes. And after that, we will have 1 class which is going to be completely on interview preparation. So how to approach HLD or how to approach LLD problems. So in this 1 class, we are going to only discuss that, okay, what are the different types of LLD problems that come up, how to solve each of them. Okay, for example, how to solve theoretical problems, what is the expectation from theoretical problems, how to solve only design problems, how to solve machine coding problems, how much time should you give to what thing, what should be your approach, what should you do first, what should you do next, etc., etc. Okay, after that we will have a lot of case studies. Now we have divided these case studies into a few subcategories. We are going to start with case studies of entities. Okay, here we will in the class, so there will be 2 parts of it, class and assignment. So in the class, we will be discussing for the entity, a pen. For the assignment, we will be trying to go with vending machine. Okay. Then we will go to games. So in the classes, we are going to design tic-tac-toe and your snake and ladders. Okay. In the assignments, we are going to have chess, and the second thing is going to be your card game. Okay. After that, we will go to the next thing, which is going to be real systems. Okay. In real systems, in our classes, we are going to cover parking lot. Okay. We are going to cover Book My Show. And we are going to cover, there are 2 more. One is MailChimp. And there is Splitwise. Okay. And then there will be 4 classes. I mean, there will be 4 assignments. I haven't yet decided the assignments for your batch. We will come to that very soon. And after that, the one last thing is going to be engineering problems. For engineering problems, we are going to discuss one thing, which is design a distributed cache. Okay. Here also, I haven't finalized the assignment yet, but there is going to be one assignment. Okay. Cool. Now the question is, did you write MailChimp? Yes, MailChimp. MailChimp. What is MailChimp? I expected this question, and that is why this problem is here. MailChimp is something most people don't know. So this class is going to help you understand how to do machine coding of a system that you have no idea about. Okay. So now another question that is there is, are we going to code this as well? So we are going to code a part of each of these systems, and the final code will be given to you, in the sense that for the current classes, I mean, in parallel, there is one more batch that is going on for which I'm taking their LLD. So in that particular batch, this was the code that we designed for parking lot. Okay, this was the code that we wrote in the class for parking lot. Similarly, there was a code for tic-tac-toe as well. This one. Okay, so in each of the classes, we are going to write a code that is going to be important for you for that particular section. Okay. And in the assignment as well, you will be required to write a part of the code, etc. Ravi Babu, CDN is an HLD thing. CDN is an HLD thing. Sagar, we will not be discussing e-commerce. E-commerce is very same as Book My Show. Nothing new to learn there. Okay. E-commerce will probably be one of the assignments. So one of the assignments probably is going to be your Amazon or Flipkart. Okay. One of the assignments is going to be Amazon or Flipkart. Okay. Bitly URL shortener is a HLD problem. Okay. Class schedule has all the details, guys. Today's topic is two concepts, so please just don't worry. I mean, the first class is for this purpose. That is why we have two object-oriented programming classes. Don't worry about that. Okay. Ankit, Aniket, I don't need to ping. I don't need to pin the links, because don't worry, these codes are going to be written in your classes as well. You can see all the code bases that we have at this particular part. Okay. Cool. Awesome. Now, one last thing. There are going to be two auxiliary classes as well in parallel to this. We are going to have two classes on concurrency. Okay. One or two class will depend upon how much time it takes. And we are going to have one class on test cases. How to write unit test cases. So this is how your whole LLD curriculum is going to be structured. Is everyone clear with that? Okay. One last question that comes up from many people, and it is already coming, is about the assignments, and what kind of assignments there are. Okay, so there are going to be, for now, three types of assignments. The very first assignment is MCQ questions. Okay, completely objective assignments, nothing much. So it's just going to ask you what you have learned in the class, nothing much. These assignments are only going to be there for OOP classes. Okay. These assignments are not going to be there for any other class, only for OOP classes. Then, most of the assignments that you're going to have are going to be for 2 or 3. 2 is going to be diagrams. Okay. In the diagram assignments, you will be given a set of use cases, and you will have to submit your class diagram or use case diagram or schema design for that particular use case. Okay. And the second assignment is going to be code review. In code review, again, you will be given a set of use cases. You will have to write the code in the good way to handle those use cases. Now, what about how will I score them? How will we score them? I mean, these are going to be automatically scored, so nothing much there. For these assignments, there is going to be 3 peer reviews. 3 of your peers are going to review the diagram, and then 1 TA will review it. So whatever the score TA gives will be the score that will be there for the assignment. Same for the code review. In the code review as well, 3 peer plus 1 TA. Okay. Now, will we be using any tool for use case diagram? Yes, Manish. So in the scalar assignments, there is a draw.io embedded. So, I mean, within the Scalar platform, you will see something very similar to draw.io, and then you can see that. Okay. Then you can just draw it within the platform itself. Cool. Will they affect PSP? Yes. I mean, these questions are going to affect your PSP. Now, there's a question. If a question requires more than one component, it's HLD. Yes, Abhinav, then that will go into HLD. LLD is not going to be that complex. Okay. Now there's a question that, okay, let us say I solved the assignment, I got the TA review after that. So for each of these problems, what I'm trying to do is, we haven't done that yet, being very honest with you, but I'm creating personally one model solution for each of the problems. Okay. Model solution with approach. So after the TA has scored you, after the peers have reviewed your assignment, just read that model solution and you will have a complete idea on what can a correct solution be. What are the different trade-offs? What are the different thought processes that should be there? I have done this already for a few problems, so I am pretty much confident that by the time we reach these classes for you, all these docs will also be ready. Okay, cool. So that is about the assignments. Any question with respect to LLD in Scalar? Will not teach how to debug and how it is done in real life scenarios. Utkarsh, here we are just going to, we are not solving debugging assignments. We just have drawing the code and doing the class diagram. So there we don't need to do the debugging, right, Utkarsh? Here we don't need to do the debugging. Here you have a complete scratch and you start from there. Clean code, Rahul, what do you mean by clean code? I mean, are we going to cover clean code? Is that what you're talking? So Rahul, I mean, the clean code is nothing but design principles and design patterns. This is what a clean code is. So yes, that is getting covered. Sanjeev, I mean, there will be different types of assignments. In some assignments, you will be asked to write a part of the code. For example, for Book My Show, right? The platform was not yet ready. So for parking lot for the current class, the assignment that was given to them is here. So this was the code base that was given to them, and they were told in the assignment that you have to implement these two things. Something like that, okay? Perfect. Yes, Sagar, obviously we will be using interfaces. Don't worry. I mean, you can see the code of parking lot. You will see a lot of interfaces there already. So yes. Vijay, we will be coding it. I have sent you the code of tic-tac-toe above, right? We will be coding the games. Okay. Can we solve the LLD questions in JavaScript? Yes, you can. Okay. Now there's a question. Will we learn TDD or BDD? Samrat, there's a class on. There was a class on test cases, right? That is going to cover TDD and BDD, but we are not going to use that in the assignments, etc. Yes, Sugandha, working on that. Yes, that's going to happen. Okay. Today's class is not going to have assignments, but I mean, all these assignments are already ready. So there you are definitely going to see the assignments. For the schema design, also the assignments are ready. UML is the assignments is ready. For design patterns and design principles, we're still working on the assignment. So that might be a bit delayed. Okay. Cool. Yes, Priyanshu. Which JDK version is required for this? Sumit, you can use any Java greater than 8. Java greater than equal to 8 should be okay. TA peers will be adding review feedbacks. Yes, Kapil, correct. All the classes will be taken by you. I cannot assure that. I will at least be taking first few classes of your batch, but let us see how it goes after that. Okay. No, Saurabh, that's not going to be covered. That is more of a HLD thing. Okay. Yes, Kumar, assignments are same in every batch. No, sorry, the IntelliJ license will be given by Thursday. Okay. Okay, one last question and then we will starting. These code bases are going to be in two things. Whatever things we are going to code in plain Java, and the last few things, the Mailchimp, the Splitwise, these two things we will code in Spring Boot. So you are going to learn the basic fundamentals of Spring Boot in these two, as well as in the schema design classes. So don't worry, your Spring Boot also, at least the one that is important for machine coding interviews, will be covered. Okay. Perfect. Yes, Manjeet, anything is okay. No prerequisite. Awesome. So I think we are ready. Yes, Akash. Yes, obviously you will be using it to submit it. Okay. I will see, Prakash. I have probably after, I mean, mid-June, I have to go somewhere. So I will see how it happens after that. But don't worry, your classes are going to be, I mean, even if I don't take them, I'm going to ensure that the classes are taken and every material gets covered. Okay. Yes, Alok. Don't worry. Even those who don't understand, yes, Vandana, you will be able to. Okay. Don't worry. Perfect. Okay. So let us start the classes now. Let us start with intro to object-oriented programming. Anyone needs a break for 2 minutes? Anyone needs a break for 2 minutes? Okay, so let us just have a quick thing. Let me have a sip of water. Let us take a break till 10:15. Let me just have a sip of water as well. We have a break till 10:15 p.m. and then we will start with introduction to object-oriented programming. Okay, cool. Awesome. Okay, am I audible? Perfect. Yes. Nishit, can you please just send that message to me on Slack? Yes, Avinash, these days LLD front-end machine coding interviews have also started happening. So yes, it is also important for front-end developer. Okay, some companies have even started asking front-end LLD, front-end machine coding questions these days. So yeah, okay, awesome. Now, I think let us start the session. Okay, so Rupesh will take at the end. Okay, so let's start with introduction to object-oriented programming. Before we even start learning object-oriented programming, let us learn a programming paradigm that we all would have probably started the programming with. Any guesses which was the programming paradigm that we all started programming with? Procedural programming, right? Before object-oriented programming, there was a programming paradigm called procedural programming. Okay. Now, what do we mean by procedural programming? So, in procedural programming, let us try to understand what procedural programming is. Procedure is nothing but the old age name for functions. What we call functions or methods these days, they were earlier known as procedures. Okay, so what is procedural programming? In procedural programming, we divide our code base into a bunch of procedures. So my code base is nothing but a bunch of procedures. There are multiple procedures here and there in my code base. Okay, every procedure may internally call other procedures. So every procedure, for example, might decide that I want to call some other procedure as well, right? For example, how in our day-to-day lives, we write methods that call other methods. Everyone has seen that? In our day-to-day lives, we do write methods that call other methods, right? Okay. Now, the execution of the program, a program starts from a special procedure. Any guesses what is often the name of the special procedure? Most of the times, this procedure is called main. And if I have to formally define what a procedure is, because here you will start finding the problems that are there with procedural programming, the procedure is nothing but a procedure can be considered as a set of instructions that take an input, that take one or many inputs, or zero or many inputs, and perform some action based on them, and may or may not return anything. Okay, quick question. What do we call these inputs these days? What do we call these inputs these days? Set of instructions that take one or many inputs. What do we call them? These are parameters. Absolutely. Okay. And the returning the data is nothing but returned, right? If a function returns anything. Okay. So procedure is nothing but a function, right? What we call a function these days. That is what a procedure is. Okay. Now, what is the problem? Shanwas, yes, you are absolutely correct. As I mentioned at the beginning, procedure is nothing but old age name for functions or methods. Okay. Now, what is the problem with this code? The problem with this code is not with the procedures, but the problem comes due to data. Okay. See, let us try to imagine a real world. Okay. Let us see. When we are trying to learn, Priyanshu will take up your question later. Okay. So let's say when we are thinking about a complex system, right? When we are thinking about low level design, are we talking about very small systems, or are we trying to say that, okay, how will my code look good when the system becomes huge, when the code base becomes huge, when there are a lot of dependencies? We are talking about large systems, right? Often the advantages of good software design aren't visible till the size of your software system becomes large, till there are a lot of classes, till there are a lot of methods, till there are a lot of dependencies. So we are thinking of a large system. And often large systems end up becoming complex. There are a lot of dependencies. There are a lot of things that are happening at multiple places. Okay? Let us try to think that how do we as humans make sense of complex systems? Any complex system that you see around you daily, any complex system that you see around you daily, that has so many dependencies, that has so many things happening here and there. Your company where you work, right? So many people doing so many work, everything is happening here and there, right? So let us take an example of your company, okay, of the organization where you are working. Okay, in the last class I had taken the example of the planet, but that most people were not able to understand, so I'm trying to take a lower version example today. So let us think about company. Okay, or Ishika, you can take an example of your college as well. That's also going to be okay. Now let us say you were the person who were, let us say you are God. Okay, let us say you are in charge of making the company work, making the college work. Whatever is happening in the college, you have to decide. How will you decide that? Let us say you are given a page. In this notebook, you have to decide what will happen in the college. How will you decide that? You have to write whatever you want to happen in the college. You just have to write that. So tell me few statements that you will write. Just 3-4 statements. So let us say you are the person who will decide what will happen in your company or what will happen in your college. And someone has given you a notebook. You have to just write the things that you want to happen in the college, and that will happen. What will you write? Give me statements. Give me statements, real statements. Okay. I want proper English lines. Proper English sentences. Proper English sentences. Not 9 to 5 work. Proper English sentence. English sentence, not words. The question is, let us say you have to decide what will happen in your company, what is happening in your current company. So you will, whatever you write in this notebook, that will happen in your company. Okay. Exactly how you say that will happen, that will happen. So tell me few sentences that you will write to decide what will happen in the company. Okay, so one thing is, so Anant has written one good sentence. Employees work from 9 to 5. Okay, so employees work from 9 to 5. Okay, anything else? People don't put out your problems that you have with your company. Just be a bit supportive. Okay, current sales bring in new customers. Okay, sales gets new customers. Okay, so everyone here has started writing statements like, for example, this is really going to happen. Just tell that, okay, you have to define the day-to-day jobs that are happening in the company. Or let me reduce the problem. The problem statement is you have to decide what will happen in the company tomorrow. So tell what will happen in the company tomorrow. Or let us say people are reporting to you and you have to tell them what they have to work upon. So again, let me make the problem statement a bit clear. Okay, let us again start from scratch because everyone here has started putting out their issues with their company. So let us not do that. Let me again change the problem. The problem statement is that let us say you lead a team at the company. Okay, you lead the team at your company. Okay, you lead a team at your company. Okay, and you have to decide. You have to decide what your team does tomorrow. Team does tomorrow. And by the way, team is nothing but multiple members, right? What your team does tomorrow. So you have to just write those things in this notebook. So tell me 3 points, any 3 points that you will write in this notebook to make your team do something. By team, every member, you have to give them the tasks. Let us say you will say A will report to Mumbai headquarter tomorrow. Mumbai headquarter tomorrow. Okay. Anything else? Yes. B will solve issue 1, 2, 3. Anything else? Every employee will give, every team member will give a status update. Okay. Anything else? Okay. C will demo the project. Okay. Perfect. So let us say these are enough. Okay. These are enough. Let us just try to understand the statements that you have written. Let us try to go into the detail of them. When you were describing what you wanted to happen in your team, how did you structure the sentences? Do you see that every sentence was structured as someone doing something? Can I say that? Every sentence that you wrote was structured as someone doing something. And it is not just you wrote, but this is how grammar is structured as well. In grammar, if you ever read Wren and Martin in your school days, or if you ever were beaten by your English teacher, you will know this particular thing, that how is an English sentence structured? An English sentence is structured as a subject, and I didn't study English much, so whatever comes after subject, okay? Subject and probably some action, something like this, right? So subject and some action that comes up. Okay, cool. So this is not just English. This is also about Hindi. Every language is structured in this way. We as humans try to think in this way. Someone did something. Let us talk about Hindi. Ram ne ye kiya. In English, Ram did that. Is this making sense? We always think about everything that is happening in terms of someone doing something, right? So yeah, Ishika has mentioned that correctly. So in Hindi there is karta ne karam ko karta se, something like that, which basically means how we structure in sentences in any programming languages. Someone, a subject doing something. Can everyone relate to this? That when we talk in our day-to-day lives, we talk in terms of someone doing something. That is how we try to describe the things that are happening around us. Okay, so okay, so now this is how we try to describe the situations that are happening around us. But now let us say that will this thing hold even if we have to describe how is our planet working? Let us say now you are God and now you have to describe how is the planet working. Will you also say something like this? Sagar sent a chat message. Sumit is completing his assignment. Will you again structure the world like this? Kind of, yes. I mean, you will try to describe everything in this particular way. Everyone is performing some actions, right? Sagar is doing this, Naman is doing that, Sarik is doing that, so on and so forth. Now, let us just go a bit above. In the procedural programming, now imagine a complex software system. In a real world, when we are talking about each of us, can we say each of us are entities? Sumit is an entity, Naman is an entity, Sarik is an entity, everyone is an entity, right? So, in a real world, in a normal day-to-day language, we talk about the world as entities performing actions. Is everyone aligned with this? That this is how we try to make sense of real world. Okay, is that making sense? Like this is how we try to make sense of the real world. Even when you hear news, you hear the news in the exact same way. XYZ did Y ABC to someone, right? Something like that. Okay. Now let us imagine procedural programming. In procedural programming, it is actually opposite. In procedural programming, actions are happening on entities. In procedural programming, actions are happening on entities. Why? Because by default, in procedural programming, entities are nothing but data, right? Entities are nothing but data. Do entities have any actions with them? Do entities have any behavior with them in procedural programming world? No. In procedural programming world, let me just repeat this again. In procedural programming, we have different procedures, and we can call these procedures to be something like action 1. Okay, then there is action 2. Then there is action 3. And how are the entities represented in procedural programming? Any idea? How are entities represented in procedural programming? Yes, Manish, I will do that. Okay. Either they are represented as variables, simple variables. Okay. For example, there is int, or let us say string student name is equal to Naman. Okay. Or what are other ways? Let us say if an entity has multiple attributes with them, how do we represent them in a procedural programming sense in C or those languages? Using structs. So there is also a construct called structs in C languages. A struct is nothing but a collection of attributes. Struct is very similar to a class. The only difference between struct and a class is a struct only has attributes. A struct has no methods. Is that clear with everyone? The difference between structs and class. A struct is only a collection of attributes, no methods in them. So a struct for student might be every student has a name. Okay. Every student has a age. Every student has a gender. Let us say this. Okay. Now, first of all, first thing, is everyone clear with how do we represent attributes or how do we represent data in a procedural programming language? Either we represent them as plain attributes, as plain variables of primitive types, or as structs. And what is a struct? A struct is like a class, but with no behavior in them. But with no behavior in them. There are no methods. Okay. It is just like a container. You can consider it to be like a container of different attributes of different types. Is everyone clear with this? Vijay, it is just like a container, because let us say if you have to store student age, student name, student gender separately in 3 variables, you don't really want that. You want one student variable that has all the 3 things. Okay. Quick question, is everyone clear with structs? Because that is going to be helpful for us ahead. Is everyone clear with what structs are? Perfect. Awesome. Now, don't worry, Pojo, you will learn that. Okay, so Jayesh had mentioned enum in Java. Jayesh, I mean, frankly speaking, Java is already an object-oriented programming language. So, I mean, we don't even talk about procedure in that sense. But enums actually in Java are not like structs. In Java, enums are full-fledged classes. In Java, enums can actually have methods in them as well. So, I will not call enums to be structs. Okay, clear? I mean, I will not call enum to be structs because enums can also have behavior inside them. So enums in Java, full-fledged classes rather than being structs. I hope that is clear with you. Yes, no? Okay, awesome, cool. Now, what is the problem with this? Now, let us say we do Jehu, we do, okay? But in the structs, we don't, okay? So in the data, so how is data represented in procedural programming languages? Data is represented in procedural programming languages either as variables or as structures. Structures are nothing but containers for different data types. That's it, okay? For different data types to represent same entity. Perfect. Now, the question is, let us say if I want student to do something, how will I do that? In a procedural programming language, if I want student to do something, how will I do that? If I want to perform some action on student, let us say I want to increase the age of a student, how will I do that? I will have a separate method. So I will probably have a method called increase student age. Increase student age. Okay. And this method or this procedure will take an attribute of what type? It will take an attribute of what type? It will first take an attribute of student type. And then it will take an attribute of, let us say, offset. I mean, like how much do we want to increase the age? And then we will say student dot age plus equal to offset. Is everyone clear with this? That if we have to do it in a procedural programming world, this is how we do it. Okay, Manish, let us say I want to just increase the age of a student, very random thing. We don't want to pass the age parameter, right? Because this student parameter has all the 3 things: name, age, and gender. It's a struct. It is a container. So it's a container of 3 things. Clear, Manish? Now, let us try to think of this as compared to how we think of the real world. In real world, we thought entities perform actions. In real world, we were talking about entities performing actions. But in the procedural language, what did you see happening just now? What happened here? Did entity perform an action here or something else happened? How will you write this thing? What happened here? Action was performed on an entity. Here, action was performed on an entity. Was performed on an entity. So first thing, do you all get that yes, procedural programming languages don't work in the same way how we think of real complex systems to work? Is that making sense? Correct, Utkarsh. Procedure changes the attribute set of the entity. Okay, so procedural programming languages don't really work in the same way how we humans think of the real world. So when a complex software system is implemented in procedural programming languages, what do we risk happening? What is a risk that can come up? If you are building a complex software system using procedural programming language, what is a problem that you might face? You might find it difficult to understand the code base because there will be a lot of procedures. Each procedure is doing something else, etc., etc. Sagar, I will explain that again. Okay, I will explain that. Shanvas will come to that again. Okay. Now let me try to explain it with another example as well. So hopefully everyone will be clear with this. Let us try to think of this world. Okay, let me get back to my world example. Okay. Let us say this planet was implemented in a procedural programming language. Okay, this planet, this is our Earth. Earth is flat, and this Earth is implemented in procedural programming language. Okay, so each of us are entities. Naman is an entity, Sagar is an entity, Prakash is an entity, Sumit is an entity, everyone is an entity. So let me just write these entities. So this is me, this is Sagar, everyone is here. Okay, cool. Can these entities do anything themselves? Can these entities do anything themselves? No. Who will be making them do some work? Who will be making them do some work? Procedures, right? Some procedures. So that procedure can be, let us say there is God that is here, okay, and you are doing this work. There is someone here and who is controlling every entity, someone who has access to every entity and can make the entity do whatever the procedure wants to do. Is that making sense? So there is someone who has a control of every entity and they can do that entity do anything by changing their parameters, by changing their anything. Is that clear? Is that making sense with everyone? Now, do you see this system is very much similar to a puppet? Entities are nothing but puppets here. This is a puppet. This is a puppet. And these are puppet holders. Puppets, can they do anything by themselves? Can they do anything by themselves? Not really. Puppets do whatever their holder or whatever their manager is making them do the work. This is how a procedural programming language works. In a procedural programming language, every entity is nothing but like a puppet. You are just a set of attributes. For example, every human, each of us is nothing but an age, each of us is a name, each of us is a gender. That's it. We cannot do anything. Each of us just have a name, age, and gender. That's it. We cannot do anything. We have no free will, nothing. There is some puppet holder who is controlling us, who is making us do whatever action they want to do. Is this making sense? But is this how we think of the world? But is this how we think of the world? No. We think of the world as Naman is doing this, Sarik is doing that, Karthik is doing that. Entities have actions associated with them. Entities have behaviors or actions associated with them. So this is your procedural world. Whereas, what is an object-oriented programming world? In an object-oriented programming world, there is no puppet holder. Each of the entity has a free will. Each entity is not just a set of attributes, but it is also having behaviors with them. For example, I will tell you multiple problems with procedural programming again, but let me just come here. So let us say this is now object-oriented programming world. Okay, in object-oriented programming world, every entity has attributes plus behaviors associated with them. Okay, in object-oriented programming world, entities control what behavior can happen on them. Entities control what behavior can be performed on them. Okay, let me give you an example of this. Okay, see, in this world, does this puppet holder have control over every attribute of the entity? Does the puppet controller know every information about the puppet? Yes, everything is exposed. This puppet holder knows the student's age. This puppet holder knows the student's name. This puppet holder knows the student's gender. Everything. So, if this puppet holder wants to change the name of Jayesh, will they be able to do that? Yes. But what if Jayesh doesn't want to do that? What if Jayesh doesn't want to allow that? Does Jayesh have any control? No. But in object-oriented programming, entities have the control of what behaviors can be performed on them and what behavior cannot be performed on them. That is why, for a complex software system, implementing it in an object-oriented programming language makes it easy to understand the system, makes it easy to understand what is happening in the system. For example, if something is happening to a person, I can say that the problem might be in a person code base, in a person class, or in the person entity. Is that making sense? what is object-oriented programming, what is procedural programming language. Is the intuition clear with everyone that why did we even come from procedural to object-oriented? Okay. Vijay, no. I mean, in procedural programming languages, in strictly procedural programming languages, every attribute is public. The attributes are not private. Okay. Because private attributes don't make any sense, right? I mean, because you are just data. What is private data? Private data is as good as nothing, right? Yes, Sarik. I mean, there are multiple languages that implement both procedure and object-oriented, so that's correct. Okay. Yes. So, Shashank, I will get there. I will get there very soon. But, quick question. So, first of all, why did object-oriented programming come into picture? Answer is we humans think of entities performing some actions, whereas in procedural programming language, it is actions being performed on some entities, which is counterintuitive. This makes a complex software system in a procedural programming language difficult to understand, difficult to resonate, or difficult to explain, because there are a lot of methods, a lot of interdependencies between those procedures, which becomes a bit difficult to make sense of. Whereas object-oriented programming is in the way we humans by default think, because we humans always say someone is performing some action. So with object-oriented programming, it makes it easy for us to make sense of a complex software system, and that is why object-oriented programming languages can end up being better for complex software design. Is everyone clear with this? Why even OOP came into picture? Because then we will go ahead with OOP. Okay. Yes, functional programming is different, Samrat. Okay. Okay. So in object-oriented programming, entities are responsible for the action behavior they perform. Correct. Absolutely correct, Utkarsh. Absolutely correct. You have understood object-oriented programming very well. Okay. Awesome. Now, so quickly writing, what are the cons of procedural programming? The cons of procedural programming is, first of all, difficult to make sense of in a complex system. Okay. It will become very difficult for you to make sense of a complex system. Understandability is difficult. Okay. Understandability of code base is difficult. And this thing also leads to difficult to debug code bases. Code bases are difficult to debug because let us say if one day humans start flying in a procedural code base, will you know that okay where the problem is? If one day suddenly you see that humans are flying, will you get an idea that okay how are humans flying? It will not be easy for you, right? There might be any procedure written somewhere which is making the humans fly. So yeah, correct. So that's not really good. Okay. Yeah. Functional programming is not procedural programming. Yes, Manish, functional and procedural are different. Okay. Awesome. Difficult to debug, so that is a problem, and it can lead to a lot of dependencies, a lot of interdependencies. That means spaghetti code. Okay, make difficult to make sense of the thing. Okay, cool. Now let us come to object-oriented programming. Object-oriented programming basically says entities having data and behavior. That's it. Okay. For now, this is enough. We will go into more detail of object-oriented programming as we go ahead. So there are a few questions. Uber had a monolithic code at first. Yes, Sagar, monolithic has nothing to do with object-oriented programming. A monolithic code base can be written in an object-oriented programming language. It can also be written in a non-object-oriented programming language. Monolith is not anywhere related to object-oriented or procedure. Okay. The object provides context to the possible behaviors. Correct, Akash, absolutely correct. But OS are written in procedural. Jehu, I mean, Linux is written in C language. No, I mean, there are multiple reasons for that. I mean, like, why did you write an operating system in C? Multiple reasons. For example, it's a low-level language, and if you create objects, it's an additional trade-off, right? So that also is one of the reasons for this thing. But yeah, I mean, there are still places where C, etc. are used, but in complex software systems, it becomes difficult to make sense of them. Okay. Is there any chance of cyclic dependency in procedure? I mean, Shanavas, that can happen. And I mean, like in that case, you will just end up with infinite loop. That's it. Okay. So Sagar, I mean, we have written the cons of procedure languages. The pros of procedure programming might be less overhead, that you don't have to create objects, you don't have to create classes, so less overhead. But I think that is the only pro that will be there for procedure languages. Okay. Can't we practice assignments in Golang then? Jayesh, Golang is a very interesting language. Golang is technically not an object-oriented programming language, but it is not 100% procedure language as well. Okay, so you can practice the assignments in Golang. It is possible to do them, but there will be some differences. Okay, Golang is kind of in between object-oriented and procedural is how I try to define it. Okay, but it's definitely not a pure object-oriented programming language. I haven't used Rust, Sarik. I haven't used Rust. Why is it called top-down approach? Suhas, not sure. Not sure. Okay. Anyways, let us go ahead. Okay. Yeah, Golang. The only reason why I love Golang is for Go routines. I hate Golang, very frankly speaking. I learned Golang twice or thrice, and I hate Golang like anything in the sense that some of the decisions that happen at Golang are something that I don't really like. I mean, why do you even need to make those syntactic sugars? Uh, I don't see a use case of that. Some people do, but I don't feel any use case of that. Okay. For some syntactic sugars, there are some benefits definitely, but many of them I don't really feel any use case of. For example, rune thing. In Golang, there is a rune and a string. Why do you need that? I mean, like character is okay, I feel. Okay. Anyways, we will debate this thing very later, but let's go ahead. Okay. So let us get into object-oriented programming now. So, how many of you have ever? This is a very thing. I mean, but unfortunately, many people already know the answer of this. Let me just try it again. How many of you have heard about something called pillars of object-oriented programming? There are some pillars of object-oriented programming, right? Quick question: how many pillars of object-oriented programming are there? 4, 5, 4, 5, 7 is also there. 7, 3. Some people have also answered. What is the correct answer? Okay, so okay. Now everyone has given the answer, right? And you can see in the chat, someone has given 4, someone has given 5, someone has given 6. Okay. If people give multiple answers, so what will you use to check the correct answer? If people give multiple answers, what will you use to check the correct answers? You will use Google search, right? Okay. Let us learn Google search. Let us see Google search and let us see the answer that Google search tells us. Okay. Yeah, I'm going to share the screen. Okay. Okay. What does the first result say? How many pillars are there in object-oriented programming? 4. But calm down. What does this say? 3. Let us just stop a bit. Okay. I think I hope I get that thing. The last class happened much better with this. So this 4, this is 3. Okay. Did you also see 5 now? Is there 5 also now there? What are 5 principles? Okay, 5 is also here, right? So there is also 6. By the way, there is also one Google search that will also give 6. So what is the correct answer? What is the correct answer? Okay, now the correct answer is very difficult to define. Okay, so this term, the number of pillars of OOP is just, I mean, it's just a term that came into practice, not really any well-defined answer of this. Okay, so let me try to explain it in the way that I like explaining. I feel that there are 3 pillars of object-oriented programming, and there is one principle of object-oriented programming. Normally, whenever someone will be teaching you object-oriented programming, they will be telling you 4 terms. What are they? These are abstraction, encapsulation, inheritance, and polymorphism. Okay, and most of the people say that each of the 4 are pillars of object-oriented programming. Okay, which I personally feel is wrong. Okay, the definition that I like going with is that object-oriented programming has one principle And what is the principle of object-oriented programming? That is abstraction. And there are 3 pillars of object-oriented programming. And those 3 pillars are encapsulation, inheritance, and polymorphism. Okay. By the way, some books also write the exact same thing. I mean, for example, if you will read the book called Java, the Complete Reference, it also says the exact same thing. Java, the Complete Reference, it also says the exact same thing about this. Okay. So I find this approach better, but some people think there are 4 pillars of OOP. Don't worry. Okay. Sagar, we will discuss composition, aggregation, solid, everything will happen. Give time. Okay. Give time to time. Wait. Okay. Let us first learn about this. First of all, what is the difference between a principle and a pillar? Okay. What are principles? I mean, if someone asks you, what do you mean by a principle? What will you say? What is a principle? A principle is a value. A principle is nothing but a value system or a quality system or quality or fundamental, something that is fundamental. Okay, so Manish is saying there they used to be called features of OOP. Yes, so all these terms are used. So I can say there is one fundamental of object-oriented programming. For example, when I was trying to build the intuition of object-oriented programming, how did I build the intuition of object-oriented programming? How did I build that? By entities performing action. So that is why the foundation or the fundamental of object-oriented programming on which the whole object-oriented programming is based is abstraction. So let us start with the very first term, which is abstraction. What is abstraction? Abstraction is foundation of object-oriented programming. This is the principle or principle or fundamental concept on which object-oriented programming is based. Okay, let us try to learn this concept. What do we mean by abstraction? Okay, will JavaScript be lesson in near future? No, anonymous. It's used enough. Okay. What do you? Okay. Let us define abstraction. Okay, if I ask you a question, what is abstraction? What will you define? Now, again, everyone will give the answer that they have learned in university. Hiding details, showing only important things, etc. Quick thing. Try to get the real definition of abstraction. Just see it in dictionary or just Google it. Define abstraction. What does abstraction means? Google it. Define abstract. Okay, see, abstraction means making something abstract, correct? I mean, abstraction is nothing but the process of making something abstract. And what does the word abstract mean? What does the word abstract mean? Yes, one person had Googled this, and the definition of the abstract is existing only as an idea. This is the definition of abstract. Abstract is something that exists as a idea. Did everyone see this definition? Abstract means something as an idea, representing something as an idea. Now the object-oriented programming will make complete sense to you. When we were trying to represent the whole planet, did we represent it in terms of ideas that there are humans on the planet, there are animals on the planet, there are in your office there is a CEO, there is an employee, there is a printer, there are different ideas, and each idea can do what? In object-oriented programming, every idea along with it has some attributes, some details, and some behaviors that they can do. So what is the fundamental or what is the foundation of object-oriented programming? Object-oriented programming works on the foundation of abstraction, which means representing a complex software system in terms of different ideas. So representing a complex software system in terms of ideas. Okay. And what do I mean by ideas? What are these ideas that I try to represent a complex software system is? These ideas are nothing but entities that have some information associated to them and can perform some behavior. Okay. So object-oriented programming says that if you are trying to do an object-oriented design, whatever complex system are there, whatever complex a system is, try to represent that system as different ideas, each idea along with them having some attributes, having some behaviors. Okay. Now, those ideas, how will that be represented, Manish? Entities are one type of ideas. There are other types of ideas as well that we will discuss later. That is why for now I'm just using the word idea rather than entities. Okay, Manish? Because there are different ways to represent those ideas. Entity is only one of them. Okay, cool. So I say in object-oriented design, represent any complex system in just terms of ideas. Every idea is something that has some details that can perform some actions. For example, let us say we are trying to build scalar. In scalar, what can be those different ideas in scalar software system? What might be those ideas? What might be those things that have some details, that have some actions, that might be working together to make your scalar system work? What might be those things around you? Students. Correct. In this class, there is an idea of student. In the scalar software system, there is going to be a student. A student is going to have some details. A student is going to have some behaviors. There is going to be a problem or an assignment question, right? Every assignment question will have some details. It will have probably, let us say, description. It will have your title, etc. Sagar, I mean, like, you are thinking on the correct direction, but I'm not going to call that for some reason. Okay. Any other entities, any other such ideas in scalar? Class. Yes, every class is an idea, right? In scalar software system, there are going to be classes. Classes are going to have some details. For example, every class will have an instructor. It will have a recording. It will have a time. Everything. Every job listing that you might get is a thing. Teaching assistant is a entity. So now, do you see that if I divide my scalar's code base as terms of different ideas, each idea being able to perform only some action, it makes it easier for me to understand that. Is that making sense? Okay, cool. Now, there is second benefit that I get from ideas as well. See, if I'm talking in terms of ideas, do I care about how that idea is working internally? Do I care about that? No. The another benefit of representing a complex system in terms of ideas is I don't care. No need to be concerned about internal workings of the system. So, for example, let us say there is some person who wants to make a student or who wants to create a new class. Will they care about how is a class going to be created? Will they care about that? Let us say there is someone called admin, and this admin wants to create a new class. This admin wants to just create a new class. Will they be concerned about the real code of creating a class? Not really. They will just call the new class method. That's it. Now the person who is implementing the new class will be concerned about it, but the admin who is just caring about that functionality doesn't need to worry about how to do that work. Is that making sense? The person who is using that functionality doesn't need to worry about how that. Okay, let me repeat that again. So for example, this is an admin. Admin wants to create a class. This admin wants to create a class. Okay. So now admin doesn't need to care about how a new class will be created. This class will probably have a new method called create. So this admin will just call the create behavior of the class and that's it. Is that making sense? So admin will just call the create behavior. It doesn't care about how is the create behavior internally implemented. What are the different things that happen? The only thing that admin cares about is the parameters of the create, and the return type of the create. That's it. Is that making sense? But someone has to define, right? So yes, Khagan. So the class, the person who is writing the code base of the class will be concerned about that. But admin, a user doesn't need to be concerned about it. Is that making sense? That is the benefit that you get from object-oriented programming, right? That a user or a client of your code doesn't need to be caring about the internals of your code. Is that making sense? Okay, now there is a better example of this. There is a very good way to explain this. It is an example of a car. Okay, if we think about a car, okay, let us say this is a car. Okay, cool. Now, we as a driver, do we care about how a car? I mean, like, let us say we as a driver, when we move the steering wheel, do we care about what happens internally in the car? Do we care about that? What happens internally in the car when we move a steering wheel? No. What do we care about? We only care about this behavior, that okay, you can move a steering wheel. That is the only thing that we care about. How internally it works, what does it internally do, we don't care about that, right? That is the thing that happens with abstraction. In abstraction, this is an idea. This idea is of steering wheel. Okay, and the only thing that I'm concerned with is the move method of steering wheel. I don't care about how it is internally implemented. I only care about that, yes, this method takes this as the parameter and I'm done. Is that making sense? Another example, Viru has given a very good example. When you solve an assignment on scalar, do you care about how internally the assignment is going to be judged? Do you care about that? No, you only give the code to it and that's it. You don't care about anything. You submit the code and then however the system works internally, you don't care about it. So what is abstraction? Abstraction means representing a complex software system in terms of ideas. Okay, and each idea will have along with them some data and some behavior. Okay, cool. And then the second thing is, we don't need to care about as a client, we don't need to care about how that idea works, about how a particular idea works internally. We only care about the exposed behavior. Okay, so in the term of car, in the example of car, do we care about this, how the steering wheel works internally? No, we only care about the exposed behavior, the part of the steering wheel that we can see. Everyone clear with that? Everyone absolutely clear? Awesome. Now, this is the idea, or this is the foundation on which object-oriented programming is based. Okay. Kapil, we will get to car later. You don't need to care about that. You just need to understand this steering wheel example. That we only care that there is a steering wheel in the car. How internally it works, we don't care about that. Okay. Correct, Shanavas. Absolutely. Akash, everyone. So you will see that happening very soon. Okay. We are just in the theory phase today. So as soon as we start writing the code, you will understand everything. Okay. Give some time. Okay. Now, this is the foundation on which object-oriented programming is based. So object-oriented programming says, whatever complex software system you get, just represent it in terms of ideas and it will make your life easier. It will make the understanding of the code base easier. So it's better approach for you. But then how will you bring this idea, or how will you bring this foundation into reality? How will you bring this concept into reality? This concept of abstraction, someone has to code that, right? Someone has to bring that into reality. Is that correct? I mean, there is a foundation, there is a concept, but how will you put this concept into reality? This concept is put into reality in all the programming languages using 3 pillars. So what are the 3 pillars? Pillars are how the concept or foundation is brought into existence. Okay, so object-oriented programming is based on the concept of abstraction. But how is that abstraction actually there? I mean, how do you implement the abstraction in these languages? I mean, there has to be some way for that, right? That is pillars. These pillars allow you to implement abstraction in programming languages. Is the difference between a pillar and a principle clear? Principle is the idea. Principle is the foundation that I will represent my whole system in terms of ideas. But how will you represent the system in terms of ideas? Someone has to support that, right? And that support are the pillars. Is the difference between pillars and principle clear? Is the difference between pillar and principle clear? Okay, let me again explain. Okay, cool. So let us say a principle is in a programming language. A principle is that I will have data. That's it. That's the principle. That I will have data in my programming language. But how do you represent data in a programming language? How do you really bring that principle into practice? Using data types. Absolutely correct. This is the meaning. So foundation is abstraction. That in object-oriented programming languages, I will have abstraction. But how will you code that abstraction? How will you work with that abstraction? There have to be some language constructs that allow you to code the abstraction, that allow you to work with the abstraction, right? Making sense? There have to be some language constructs that allow you to work with the abstraction, that allow you to code the abstraction. So what are those language constructs? Those language constructs are known as the pillars. There are three pillars of in object-oriented programming languages that allow to represent the idea of abstraction. So idea of abstraction is represented by three pillars: encapsulation, inheritance, and polymorphism. We are going to go into detail of each of these three. Don't worry about that. And after that, it will make more sense. Okay. Cool. So again, summarizing it again, because there were a lesser number of people who told a yes. So object-oriented design is based on the concept of abstraction. It says that a complex software system that I will represent that complex software system as multiple ideas. Each idea will have attributes, each idea will have behaviors, and that is how I will make my code base understandable, easy to navigate, easy to explain, etc. That was the foundation. That was the idea that I had. That was the principle, or that was the vision that I had. But someone has to bring that vision into practice, right? For example, a founder of a company has a vision that I will build, let us say, the next Stanford. Okay. But someone has to bring that vision into reality, correct? Who brings that vision into reality? These are the pillars. Pillars are the people who support your vision. Pillars are the people or the concepts that support the vision, that okay, vision to represent a software system in terms of ideas. What are those pillars? Those pillars are encapsulation, inheritance, polymorphism. Is that making sense? So I will bring abstraction into practice by having encapsulation, inheritance, and polymorphism. So for example, Anshuman says, I will try to build the next Stanford by having a lot of instructors, by having a lot of career team, etc., etc. Is that making sense? Yes, Ishika, you are absolutely correct. I mean, that is your target. Abstraction is the target that you want to achieve. And this is how you will achieve the target. Pillars are support to achieve the target. Okay. Is that making sense? There are 212 people in the class right now. How many are clear with this? Say a yes. Okay. Say a yes if you're clear. Okay. Everyone is clear. That's nice. Okay. Now, let us learn only one of the pillar today, because after that, everyone would have already become, I mean, it's a theoretical class. So everyone might starting getting bored there. So let us start with the encapsulation. What is encapsulation? Okay. When you read the word encapsulation, is there a word that you see in your day-to-day life that is coming into your mind? Capsule. When you read encapsulation, what comes to your mind? Capsule. Okay. Where have you seen capsules in your day-to-day life? Medicines, right? We often see capsules in medicines. Okay. When we see capsules in medicines, what is the purpose of these capsules? I mean, like, why are these capsules helpful? What do these capsules do internally? I mean, like, what is the benefit that they do? I mean, that allow you to eat the medicine, but what goes inside these capsules? So capsules have actually two works. Capsules have two work. The first purpose of this capsule is that, okay, you have a capsule like this, and internally in the capsule, there is a medicine, right? There is a medicine, something like that. Okay. So capsules have two benefits. The very first thing is they hold the medicine together. Is that correct? They hold the medicine together so that, I mean, they are way to store the medicine, right? Either you can store the medicine in a packet, or you can store the medicine uh, in a, I'm not sure how many of you have seen that, but some people even store the medicine in a newspaper or toffee wrapper as well. But they are nothing but a way to store a medicine. The second benefit that they provide is they prevent the medicine from external environment. Is that correct? They also prevent or protect the medicine from external environment. Okay. And the third thing, which I think someone had mentioned, normally this thing, right? I'm not sure how many of you have seen this. The taste of the capsule is often better than the taste of the medicine. So if you will eat this medicine without the capsule, right, you will have a very bad time. But if you eat with the capsule, you have a better experience. Okay. So they give a better experience to the outside people, give a better experience to users of the medicine. Okay. So is everyone clear with the three features? Features? Perfect. These are the exactly three features that encapsulation in object-oriented programming has. What do I mean by this? Encapsulation in object-oriented programming says, I will first hold the medicine together. What do I want to hold in object-oriented programming? What do I want to hold together in object-oriented programming? Data, and there is something more. There is something more. Behavior. Data and behavior. So encapsulation in object-oriented programming allows you to store data and attributes of an idea together. Attributes of an idea together. Perfect. Second, protect the medicine from outside environment. You hide the unnecessary details, unnecessary or irrelevant details from outside influence. How do you do that, by the way? If anyone already knows, I mean, we are going to learn that, but if anyone already knows that, how do we hide the details? Access modifiers, public, private, protected, default, right? Third thing, give a better experience to the users. Only expose to clients what you want to expose. What you want to expose. Is encapsulation clear with everyone? 3 points, simple. I mean, they are same. I mean, second and third point are same. I'm like, hide the unnecessary details and only expose whatever you want to. Okay. How it hide attributes, we are going to come to that. Okay. Shinaz, okay, let me now discuss it in practice. We have discussed the concept of encapsulation, but now how is encapsulation represented in programming languages? Correct point 01. Utkarsh, what do you mean by that? Amit coming there. Behavior missing. Oh, sorry, data and behavior. Sorry. Thanks, Utkarsh. Okay, cool. Now, how do we do this encapsulation? How do we implement this encapsulation? This encapsulation is implemented using something called classes. So let us introduce the first terms of object-oriented programming. The very first term related to object-oriented programming is a class. a very fundamental term. What does a class mean? A class is nothing but a blueprint of an entity. What is a blueprint, by the way? What's a blueprint? What is a blueprint? What's a blueprint? Has anyone seen this word blueprint in your day-to-day job? Civil engineering, right? If you have ever gotten a house built, if you have ever gotten your own house built, before you get your house built, you go to an architect and you tell the architect that I want to build a house here. And the architect gives you a blueprint of the building. They say that, okay, I will be having in my building, I will be having a room here. I will be having another room here. I will be having a washroom here. Then I might be having a kitchen here. Then I might be having another, whatever, garden here. And here might be a drawing. Okay. This is a blueprint that an architect gives to you. Okay. Same way, class is a blueprint of an entity. So a class says that for a particular type of entity, what will be the different things inside it? What will be the different attributes inside it? What will be the different behaviors inside it? So for example, for scalar, there might be a class called student. Okay. So scalar will say for every student, I will have an age, I will have a name, I will have an email, I will have their batch, okay, and I will have their PSP. Is this making sense? Okay. And similarly, every student also has a few behaviors. So every student is going to have a behavior of, let us say, change batch. Okay. Every student is going to have a behavior of pausing a course. Okay. Every student is going to have some other feature, whatever. Okay. Cool. Change mentor. Yes, change mentor can be a good one. How many of you here have changed their mentor? Just wanted to get an idea. Oh, many people have done that. Interesting. Anyways, so that's interesting. So, okay. So these are the few methods that a thing might have. Okay. Now, it is like a blueprint. Any student that will be there in Scalar will have the same, will have these particular attributes and will have these particular methods aligned. Every student that will be there on Scalar, this is the blueprint for every Scalar. Every student. Every student will have these attributes. Every student will have these behaviors. Okay. Tell me, is a blueprint really existing? Is a blueprint really in existence? I mean, is a blueprint a real house? Is a blueprint real house? No, it's not a real house. It's just a diagram. Okay. Can one blueprint be used to create multiple houses? Yes, it can. You can use one blueprint to create as many houses as you want, right? For example, if you're in a society, you will get one blueprint created and then you will replicate the same blueprint for every house that is there in the society. Perfect. That is the exact same concept with a class. A class doesn't occupy any memory. A class has no real existence. It is just a blueprint. That means it doesn't take any space in the memory. Any space in the memory. No space is occupied. It is just a blueprint, right? Karthik, and we will get to that. We will get to that. Okay, don't worry. All these questions I know. So I have seen that multiple times. So don't worry about that. Okay, cool. Cool. So class has no real existence. It doesn't take any space in the entity. And for one class, can I create multiple real instances? Can I create? Yes, I can have multiple real instances of a class. Real instances of a class. And this is how I get the second term. And the second term is object. So the first term was class. The second term is object. So what is an object? Saurabh, we will get to that. Don't worry. All of these things are going to be covered. Don't worry about that. Okay. Object. What is an object? An object is a real instance of a class. Object is a real instance of a class. Will it occupy memory? Will it occupy memory? Yes. Object will occupy memory. Right? Because this is a real house. So it will take space. It is storing the data. It is actually storing the data, right? It actually stores data for every stores data for every instance. Okay. Good question. In the scalars code base, will Anubhav be an instance or will Anubhav be a class? Anubhav will be a instance. And what will be the class? What will be the class of which Anubhav is an instance? Yes, Anubhav is an instance of student. Anubhav is an instance of student. Absolutely correct. Similarly, can I say Mahip? Is Mahip also an instance of student? Yes, Mahip is also an instance of student. Okay. And who was an instance of bad student? There was someone uh, who was doing something, right? Yeah. Okay. Now there is a question: difference between object and an instance. Manish, object is an instance. Object is same as an instance. Okay. Object is an instance. Object and instance have no meaning, no difference. Object is the real term, and instance is just an English word. That's it. Okay. In software engineering term, we call it object. We don't call it instance. We call object. Okay. Object is an instance, but instance is an English word. Object is a software engineering word. Cool, Manish. Perfect. Now, yes. Okay. Now I think there were one question that was somewhere. I am probably missing. I'm not sure. Okay, difference between instance and implementation. See, implementation is the class. You don't implement an instance. You implement a class, right? And you then create multiple instances out of it. So instance and implementation have no relation between them. It is just as difference between apples and oranges. No relation. Okay. Instances, I mean, you implement a class, and once you have implemented a class, you can create multiple instances out of it. Okay. Implementation is writing a code. Instances, I'm just creating an instance out of it. Okay. Okay. Now the question is, which I wanted to answer, which was asked earlier, was abstraction versus class. See, what is abstraction? Abstraction is the pillar. Abstraction is the principle. Abstraction is the idea behind object-oriented programming. How do we implement abstraction? How do we implement abstraction using, what was the first pillar to implement abstraction? What was the first pillar? Encapsulation. And how do we represent encapsulation in code base? How do we represent encapsulation in code base? Using a class. So a class is a way to achieve abstraction. Is that clear? A class is a way to achieve encapsulation. Encapsulation is a way to achieve abstraction. Cool. I think that should be clearing the things for you. Okay. Cool. Now, what we are going to do is we are going to do some basic operations, some very basic things in the next 5 minutes, and then we will go ahead. Vijay, we will introduce interfaces tomorrow, so let us not go ahead, okay? Because we have a lot many students with different backgrounds, so let us cover things sequentially. Otherwise, it will make things a bit difficult for everyone. Okay. Cool. Now, let's do a very simple thing. Let me create a class. To create a class based upon the current knowledge that I have, I will just create a class student. Okay. And let us say every student in my code base has a name, has an address, has an email, okay, and has a batch, okay, and has a PSP. Okay, cool. Perfect. And let us say the few methods are change batch, okay, and one is pause course. So let us say pause course. So that means there will be one attribute as well, which is, let us say, state. Okay. Okay. Now, so let us say it is a string state for now. I mean, string is not the best way to do this, but we will learn the best way to do this in the next class. Okay. So this is a string state. Now, it is a class. Is it taking any space in the memory? Nothing. No space at all. Now we will create a real instance of it. So how will we create a real instance? I mean, like how exactly this code is working, we will learn about constructors tomorrow. But simple thing is, let us say I want to create an instance of Karthik. So I will say student. For example, how do I create an instance of an integer? Int a is equal to 2, right? Same. Int student Karthik is equal to, instead of 2, I will write new student. Clear? Now, is Karthik a real instance? Is Karthik a real instance? Yes. Is Karthik occupying memory? Yes, Karthik is taking memory now. Now I can say Karthik. Now, if I want to access any attribute, I can say Karthik.name is equal to Karthik. Karthik.address is equal to, what should be the address of Karthik? Yes, Manish, this is the interface. This is how you create a instance of a particular class. Okay, Karthik.address is Mars. Okay, Karthik. Okay, email is equal to something. Okay, whatever is the email, and then I can set any attributes. Now, if I call any method, if I want to call any method of Karthik's instance, how will I do that? Again, I will say Karthik dot change batch. Is that making sense? If you want to access any attribute or any method of an instance, you will say the name of the instance dot name of the attribute or name of the method. Basic things. We haven't gone much into detail, but is it clear? Okay, perfect. Let us do that, Sagar. Let us do that. So let us implement this in the code, and then we will end the session. We don't have much more concepts to learn for today. I think we are already at 11:30, but yeah, just give me one moment. Can you see my screen? Okay. So let us implement this project for your batch. This is going to be scalar, LLD, and this is June batch, June 2022. This month, so many batches are starting with LLD. So yeah, scalar LLD June 2022, and create git repo, Java IntelliJ. This should be okay. Create. Why is that word student required on both sides? I mean, Manish, that is the interface of Java. And there are also multiple reasons of it. You will see that very soon in the, what we say. You will see those reasons very soon. Don't worry. Okay. Can everyone see the code base? Okay. So in the very first class, let me just create a random package to divide this into multiple folders, which is intro to OOP. Okay. In intro to OOP, we are going to create one simple class, which is student. Okay. In this student class, Manish, all these terms will come up. Please don't go ahead. There is a reason why I'm not going ahead. Okay. Consider for now it to be a folder. There is a reason. Okay. Because we will come to these concepts one by one. Okay. For now, I will say a student had, what were the attributes that a student had? It had a name. It had an address. It had an email. It had a batch. It had a PSP. It had state. Okay. And it had two methods, change batch. Now, how do you define a method in Java? Obviously, every method should take some parameters and should return something. Will change batch return anything? Not really, right? Change batch will not really return anything. So let us say it returns void. And what should be the parameter that it should take? New batch, the new batch, right? Let us say string new batch. Similarly, I will have pause course. And will it need any parameter? Pause course. For now, let us say nothing. Okay, it's just a duration. So I will just change the state. Nothing more than that. Okay, cool. But in real system, yes, in real scalar code base, it will take. But for now, in this implementation, let us say I just change the state to pause. Okay, awesome. Now, first thing, when I change the batch, what should I do for the student? Yes, these methods are defined in the class. Okay, you define the methods in the class, so the behavior for every instance of that class will remain the same. Okay, every instance of the class will just have different attributes, but everything else will remain the same. Yes, so change batch will do nothing but it will say, batch is equal to new batch. Okay. Similarly, and I hope all of you know about this attribute. So this dot batch is equal to new batch. Similarly for pause codes, what will I do? I will say this dot state is equal to, let us say, paused. Perfect. Simple thing, nothing more than that. Okay. Now, let me create a main class. Let me create a main class from where I will run this program. Okay. So I will create a main class and let me just create a main method here. Yes. Yeah. Okay. Now, what do I do? Till now. So let me just have a print statement doing something. Let me debug this program here. Okay. Is there anything? We are just debugging this code. Do you see any attribute here of student? Is there any attribute of student? No, nothing. Class has no physical existence. It is taking no memory at all. We have created 0 students in my code base. Now I will create a student. So how will I create a student? I will, in my main method, I will probably say student Sagar is equal to, so student Karthik is equal to new student. Okay. So you say Karthik is a variable of type student, and in this variable named Karthik, put an instance of student, put a new instance of student. You can consider it in this way. Karthik is a variable of type student. In this variable Karthik, put a new object of type student. Clear? I think, Manish, this explanation might help you a bit, but still the final thing will become clear tomorrow in the next class. Okay. Now we will say Karthik dot name is equal to Rupesh. Let us do this. Let's not do this. Let's not do this stupid things. Karthik dot name is equal to Karthik. Okay. Karthik dot s is equal to here words. Okay. Karthik dot let us say state is equal to active. Karthik is currently active. And let us say after this I want to change. I want to say Karthik dot pause course. Is this a best method? Not Karthik, and we will get to these things. We'll get to these things. We're just learning the things. We're just learning basic things on how to access attributes, etc. We'll get later to everything. Okay. Yes, we do. We don't need to. Okay, we don't need to import this instance. Okay, fine. Now let us debug this. Good. Now I am at this particular line. I am at the line this. Is there any object in my memory till now? Can you see any object in your memory right now? Nothing is there, right? No object is there. Let me go to the next line. Now, is there an object of type Karthik? Is there an object of type Karthik? Yes. Is there an object of Karthik? Yes. And Karthik is an object of what type? What do you see here? Karthik is an object of student. You can see student, right? Student here. Cool. What is the current value of Karthik's attributes? What is the current value of Karthik's attributes? Everything is null. Everything is empty because I didn't set anything. The name is null, the address is null, the email is null, the patch is null, the default values. Let me go to the next line. See, in this line, I'm going to set the name of Karthik, right? So what should happen after this? The name should become Karthik. Cool. So let us go to the next line. Do you see the name has changed? Now Karthik has a name called Karthik. Yes. Now let me go to the next line. State has changed. Address has changed. Karthik is now living at scalar verse. Let us go to the next line. Karthik is now active. Can you see how to access the attributes of a particular instance? You are able to see that. Now let us proceed the method. Okay. What does null represent? Jehu, null is nothing. Null is nothing. Okay. Cool. Now we will try to pause the course. So what do you think will happen when I call the pause course method? What do you think will happen when I call the pause course method? It will go inside that method and do what it wanted to do, right? So let me click this button. You are going to see what exactly will happen. As soon as I click this button, do you see that the execution goes in the pause course method of student class? Do you see that? The execution goes into the pause course method of the student class. And what is the next line that will be executed? What will be the next line that will be executed? This dot state is equal to paused. Currently, what is the state of Karthik? Currently, what is the state of Karthik? It is active. Let us just put the next line and it is paused. Can you see that? So as soon as I called a method of Karthik, it went into the student class and went here. Then let us go to the next line. I am going to print do something and I am done. Is everyone clear with the basic functionality of very basic thing, very intro ABCD of this, okay? And because everyone wanted to do this in the student class, let us have a method called Karthik, okay? And this method called Karthik does nothing but it prints Karthik, okay? And now in the main class, from the object of Karthik, we will call Karthik, okay? Karthik calling Karthik. Cool. Happy everyone? Okay. So now Karthik has called Karthik and no Manish, this is the constructor. This is the constructor. Okay. This is the constructor. This was just a method. This is just a method named Karthik inside students. Okay. This is a method named Karthik in a student. Okay. Yes, Saurabh. By default, all the members are not public. They are default. And we will learn about default tomorrow, Saurabh, right? So there is a reason why I'm not talking about them today. For now, assume that everything is public. Okay. It's not really public. It is default, which we will learn about tomorrow. Okay. Awesome. So that's all for today. Anyone has any doubts? By the way, Manish, constructor is this. This is the constructor. If you have any doubt, this is the constructor. Okay. Yeah, it can be. Yes, Manish, it can be. This is the constructor. Okay. This is just a method. This is just a method called Karthik in student. Okay. And let me just give you another instance. Let us create another instance as well. So now let us have another student. Student Naman is equal to new student. Okay. Then student, then Naman dot name is equal to Naman, and Naman dot patch is equal to best patch of scalar. By the way, internally in the scalars code base, there is actually a best patch of scalar. If I ever show you in Inspector dashboard, I mean, when Scalar was testing their project, internally they had actually created a best batch of Scalar. It was just for testing it. No one had that batch. It was just for testing. Only the tech team is there inside it. And let us say Naman calls the method called Naman calls Karthik. So now Naman has called Karthik. So this is a method. Okay. So let me just run it. And Naman is calling Karthik. And if I want to debug as well, let me just debug it. Cool. Now, at this particular time, we have no instance. Let us go to next. Now we have a Karthik, and after this, we will have a Naman as well. So now there are two objects of student. Can you see that? One is Karthik, another is Naman. Two objects, both have their own data values. So Karthik has its own data value, Naman has its own data value. Simple. Every instance is independent. Clear? Yes, Shubham, it will be covered. Everything that is important, don't worry, will be covered. Okay. Is that clear? Rupesh, we will learn about static methods. We are going to cover that. So then your doubt will be answered. Fine. Perfect. So that's all for today. I think, hope you had a good time. I will be uploading this code base. Let me upload it right away. Let me upload this class. Yes, both instances are parallel, Rashmi. Both instances have their own state. You can do whatever you want to them in parallel. Okay. Yes, Sagar, of course we will be. Let me go to terminal. Git and git commit m. Finish intro to boot class. Okay. Perfect. And then I think let me just git push it. You can see the code base here. Okay. Yes, we have Git integrated with IntelliJ. So yes. So this is the code base for today. Feel free to go through it and do let me know if you have any doubts. The notes will be uploaded as soon as the class ends. Okay. Cool. Awesome. Any questions, anyone? When Scalar Verse is starting? I think it has already started. Just join the Scalar Verse channel on Slack. That is best for your information. Hashtag Scalar Verse. Perfect. Ganesh, good. It's a GitHub. You will learn GitHub in the project building module. Don't worry. Kishan, let us discuss that on the Slack. Okay. Yeah, Scalar Verse is live in HSR. I think. Okay. Anyways, I think we are too much out of time. Thanks all for attending. Have a good time. Bye bye.